All right. Welcome, everybody. Thank you for your patience. I'm Peter, the President of the Space Association. Welcome to the September 2019 meeting. Thanks for coming out. It's a bit chilly tonight, but I'm sure we're going to have a good night. I've got a fair bit of content to cover tonight. I'll start off with an apology, though, because the person that actually is the brains behind this organisation, Michael Abdillah and Angela De Grazia, they've gone overseas. So they left me to try to organise things, and as per usual, I've fallen short, but please bear with me. We'll jointly we'll jointly source the intelligence to run this meeting tonight. So tonight we've got our usual sort of feature or sequence of things. We'll just do a quick update of what's happening around the association. Then we've got a very special guest to speak with us tonight. He's been to a number of meetings, but we have never really given him enough time to talk about his incredible experience and recollections. So we've got John Swannie here in the room, so fascinating guy. And then we're going to talk about, we have our Australian Space Agency Watch, which quite a packed little agenda tonight. You've been watching news in the last couple of days, so it's been quite interesting. Unfortunately, Troy contacted me this morning, a family emergency. He's unable to make it tonight. Troy McCann from Moonshot, he was very apologetic about that. Am I going out? Is something happening? So we'll have Troy in again another time. He's the founder of Moonshot. Then we're going to have a quick break, have a chat, relax, say hello to someone you haven't met before, catch up with old friends, etc. And then we're going to have space industry update of news, so we'll do part one of that. Angelo normally does that, but once again he's away. I'm getting feedback. And then Andrew Rennie, who's not here at the moment, he's out watching a movie. He's a member of the Australian Film Institute, so he goes out and reviews movies. He's at the brown light. He's focked up tonight. He's on the turntable. Yeah, there you go. God help us all. And then we're going to be thrown out about 10 o'clock, and they'll probably beat us up outside like usual at 10 o'clock. No, that's fine. So thank you again for coming out. So just not a whole lot going on around the association. We had a big frenzy of activity a couple of months ago in July with the Apollo 11 anniversary. We do have an ongoing program of activities by the association, so I thought I'd go through those with you. As you may or may not know, we do a Space News segment, which is part of Andrew's radio show we called Space News. We're also podcasting out as a separate standalone news roundup each week. At the moment it's going up via YouTube, but we're going to probably be doing something else with that. Obviously we're running our meetings and they're live streaming, and you can watch any of the meetings that have taken place again back on YouTube. We're talking about possible events around the upcoming anniversaries of Apollo 12 in November and Apollo 13 in April. No plans fixed at this stage, but the people we ran the event on Apollo 11 with out at the Sun Theatre are all over us and very keen to work with us on doing something, and it was a lot of fun, and so we might do something like that. I don't know, is anyone aware whether or not there's a reissue of the Apollo 13 movie for the anniversary of the actual mission? Anyway, has anyone heard any of that? I thought maybe they might do like a director's cut or something. Anyway, if they do, we'll jump onto that perhaps. Any ideas? We'll love to hear about it. We're always on the lookout for good speakers, and anyone that you know, or if you've got a subject that you'd like to talk about, provided it's related to space, more than welcome to, and you're not flat earth and you're not a hoaxer, you're more than welcome to come up and talk. UFOs, there you go. Well, the US Air Force have proved it now. That's actually happened. There you go. So people may or may not know about our radio program called The Space Show on Southern FM, 88.3 Southern FM. It goes out via FM. If anyone in the room remembers what FM is about, yep. It also live streams and podcasts there as well. So that goes out of the studio in Brighton now. It's moved around a couple of times, but now it's in Brighton. So it began in 1991, would you believe it, as a half-hour show on Sunday afternoons. And then it was promoted to an hour a week, and it switched on to Wednesday evenings. And it's been on air every week since then. Christmas, Boxing Day, Grand Final Day. Well, they don't run it on Sunday, but on Wednesdays, but you know, any time it's been on. Now, this is a picture I found of Andrew Rennie when he first started doing the show in 1991. And this is what it looks like now. So you can see what happens when you do, was it 18 years, 28 years of 28 years of radio, goodness me. But unfortunately Andrew's not here. I thought he'd like to see this, but he got life. He was awarded as a life member of the station. So this is what they wrote in their on their newsletter about Andrew. So he's a celebrity around the station and puts hours and hours and hours of effort into the show and preparing it, running it, etc. Writes everything out by hand, doesn't use a computer, but it's Andrew. And so congratulations to Andrew. We'll pass it on to him again when he gets here. So I think it's a great achievement. Just a reminder, in case you're not familiar, when we do run our meetings, our formula for each meeting is the fourth Monday of every month except December. At this stage, we've got December the 15th happening. The fourth Monday of December would be like Christmas Eve or something, so we're not going to do that. So last 3 meetings for the year in your calendar. So come along, we'll have some fun. The Space Association is a member funded and run organisation. No one gets paid. It's all based on contributions by members and occasional sale of events and items, etc. So if you're not a member, come see Tim. If you are a member and you want to renew, come see Tim. And if you just want to give Tim some money, actually I'm going to give you some money. That's right, yes. That's right. They are overseas. They told me it was, yes. I'll look into that. They might put in a claim, that's it, yeah. All right, so I've mentioned to him a moment ago. So John Swannie has joined us, and he's right here. And John has vast experience going back to the black and white days, well, the old days in the Apollo Gemini. I don't know how far it goes back, but anyway, John will give us a full rundown. John Swannie. So if you can stand here, I'll move the slides for you. I'll just stand behind you.
Behind me? Okay. Thanks, Peter. Thanks, each one of you for coming and for listening. My humbleness exceeds me. I don't have a vast experience of tracking stations.
On the screen here, you can look at that if you want.
Essentially, I had a relatively short experience in the stations compared to some, but I did spend 2.5 years at Aurora Valley and 4 years at Carnarvon. But fortunately, those years covered right through the initiation, the installation, virtually the building of the Aurora, or the equipping of the Aurora Valley station, and we were still laying cables under the floor as we were getting into operation. In fact, the official opening wasn't until nearly 6 months after that. So most of you will probably be aware that tracking stations have to be in a somewhat secluded area. That's the Aurora station, hidden in a valley about 40 kilometres out of south of Carnarvon, down through the whole of what was the Woden. I'm not sure if there's another district south of that, Tuggerah or something like that, isn't it? Yeah, Tuggeranong. Yeah. So I started there in September of 1965. So my memories are probably even better than Andrew's, going back to, it's over 60 years now. I was over 60 years? No, over 50 years. Now, okay. So I had previously spent 8 years with the ABC television, and once again I found myself in a very fortunate position, just being having the right education and the right practical experience as the electronic industries were becoming advanced, and then as the space program got underway. So I was actually in Rockhampton. I'd done my initial training here grew up in Melbourne, and did my technical training. Being filtered? Filtered but not censored.
There you go.
Okay.
Done.
So I had again started with the ABC just after the Olympic Games, and that stimulated the ABC to and all the television stations in Melbourne, and essentially they had to collaborate to provide television coverage for the Olympic Games in '56. I had left school a couple of years before that and was working in a transformer manufacturing little factory in Flinders Lane, off Flinders Lane, and so with those few years of experience in the early days, I was able to get a prime position when the ABC wanted to recruit groups of 10 young men to undergo television technician training. So at 19, we're off to the RMTC, the Technical College as it was then. It's advanced in status nowadays, and did a 4-year part-time course there. Once again, essentially, I found myself almost installing cables in the studios at Ripon Lea as we were getting ready to produce programs for airing. There was no recording facilities there except telerecording, and they were pretty terrible. They were fuzzy, so virtually everything went to air live every day and every night with restricted hours. So I think it usually started 3:30, 4 o'clock something in the afternoon and closed down at 10 o'clock after playing God Save the King, the Queen. 56? Yes, the Queen. Yes. Anyway, played God Save the Queen and switched off everything and went home. So I'd finished my full television technician training there, so that was great grounding again. And I found myself in a fortunate situation of being in the advanced field. I got a promotion that actually took me up to the newly established regional studio at Rockhampton in Queensland. So again, before the advent of synchronous satellites and instantaneous transmissions everywhere, there was no coax cable. There was only limited microwave linking of programs between the cities. Sydney was at the end of a very tenuous series of links of microwave links from literally hilltop to mountaintop through the Alps and across the border and into Sydney. I think there was about 11 links, long distance links, and so there's a lot of ABC. In fact, again, a combined effort between the stations to provide microwave links to get some form of programs continuously into Sydney, and that was just a start. So I was in Rockhampton for a couple of years, and again we had just to backtrack a little, at the last year in my after training at Ripon Lea with the ABC came a major advance in the television industry, which was videotape recording, and that was on a 2-inch tape running at I think only about 15 inches a second through, but it used a transverse recording across the track of a very wide tape. I don't think there's too many of those around because they all come now in a little box and they're stacked like this, but it was a big event when two of those machines arrived from the States, and two in Sydney. And that was the extent of the recording facilities, but it was a major advance to, especially in programming, that programmers could then pre-record programs as they do, and all kinds of aspects. But in those initial days, also there was no editing of tapes. That didn't come for several years after that. So I had moved on up to Rockhampton, and the year or so after that, in the Australian, I think it was, for some reason I was following the Australian because that had just started publishing in the mid-60s, 64. And I saw an advertisement for electronic technicians in the new field of satellite tracking. I think it was subtly disguised, actually, but when fortunately an interview team, which turned out to be the manager of the station, came all the way up to Rockhampton and also to Townsville, where the ABC had another team of technicians, and I got a job back at Aurora. So I started here at Aurora in late '65. Now, that's true. Yeah. So next hill up to over there, isn't it? On the hill top somewhere there's a I think probably about there's a microwave link tower linking the two. That came later. We didn't have any communication. Well, Honeysuckle wasn't there even in the early days. Now the purpose of Aurora was that it was one of the where do we go to?
Use the next slide.
Next slide.
You just push this.
Whoopee!
So, okay.
Yeah.
Push up under the right,
Okay.
and then we'll go to the next one. If you want to go back,
Yeah.
you push it.
Okay, wait. Now, the prime resource at Aurora was this 85-foot, 26-metre diameter tracking station, tracking antenna, an XY mount. And the reason for this, which is different to other pictures that you'll see of bigger dishes, is what they were going to be tracking. NASA had organised itself into three sub networks. Aurora belonged to the STADAN at that time, the Satellite Tracking and Data Acquisition Network. There's acronyms all over NASA, starting with itself. So this was the workhorse network. There was varied between 13 to 15 of these stations around the world, and they were scattered around. And the reason for this size of dish and the XY construction of the tracking was that they had to be able to manoeuvre quickly, because it was at that time supporting satellites that were in low Earth orbit, usually 200 to 300 kilometre above the surface, with a rapid orbit time of about 90 minutes. And that gave the horizon-to-horizon transit time of a satellite rising over the horizon at one point and rising to its zenith and disappearing on the other side of anything of 8 to 10 minutes. It was unusual to have well, it was impossible to have a low Earth orbit of more than about 10 minutes transit time. Quite often, if it was necessary to actually track a satellite pass that had low elevation, we may only have a 2 or 3 minute acquisition. So to be able to do that, this had, I'm not sure of what what the size of the hydraulics were, but they were very powerful. They could shunt this antenna across the sky very easily. Within about 3 minutes, they could actually drive that whole antenna from side to side. It was a bit hectic when a satellite actually passed directly overhead of the station, because the axis would have to swivel around in an XY as distinct from what an azimuth and elevation structure will do. All right, what comes next, please? Yeah. Okay. Now this again at still at Auroral, there was about so there's only one of those big 85-foot antennas because they were pretty pricey. This is a Satan antenna, and there was 4 of these, and they're used for both receiving and transmitting commands to satellites. Again, it's that's actually an ASL structure. Oh, going too far. There was 4 of those sitting in various sites around that small block of the site. You'll notice the lovely low cloud cover. Now, Auroral worked around the clock, 24/7. We had 4 shifts. I was a shift supervisor of one of those groups, and each shift actually was divided into 2. I was fortunate to manage the large 85-foot antenna, and another shift supervisor actually managed the other 4 of these Yagis there. We had a quick turnaround. We could the station was required to support so many different types of satellites with different experiments, different transmitting frequencies, different data rates. We had an operations plan for every satellite. There was usually we'd be supporting probably about 10 different types of satellites at a time, and they sequenced with their according to their lifetime and the data requirements from particular experiments. Everything was dictated and scheduled by Goddard Control Centre in Greenbelt, Maryland. And we had to be able to reconfigure our support from one type of satellite to another, and we were generally allowed only about 10 minutes to reconfigure completely our operations room. Let's see where there was different types of satellites that we've supported. Was the Nimbus group. There was a series of 3 Nimbus things, and obviously they were meteorological, cloud sports, experimenters, an orbiting astronomy. The very first of the orbiting astronomy OAO orbits, which went up and got lost. The very first one. But that was the precursor of the Hubble observatory, much later time, which worked a lot better, but then found that it was a bit foggy in one eye, I think, and had to be corrected. The weapons research satellite, we did a quick support of the satellite. An Australian Australia's only satellite that it launched, but it was designed and constructed at Weapons Research in Salisbury. I think it's in that's where it was based. Constructed and launched from there. Lasted about 3 days. 3 days more. Good. 3 weeks. Relatively short time for satellites because and it was in low orbit, of course. And yes, it was, wasn't it? I think it went slightly astray on launch, but not too much. Surprisingly good effort for a first. That's typical of the computer system. Now it's where are we at? I think that's a telemetry chart. In the early days, we actually had to get make recordings of analog data that was being transmitted from these experimental satellites, and actually record them briefly at the correct time, probably in response to commands that we'd been instructed and scheduled to transmit to them as they went overhead, and actually read out parameters on a chart like that. It was a pretty tricky business to actually get a reading there. Essentially, they'd be like a bit of an ECG in the main. Sometimes they're actually an actual digital stream that was just on and off, and you'd literally have to find the reference point and figure out which was the exact slot that you were required to report on, and actually report that back real time as this operator is doing right there through his headset. There. Now, this comes later. Actually, it's more appropriate to my work at Carnarvon, but it's the innards of a 642B computer. There was 3 of these units stacked side by sides for the Apollo mission. We might come back to that later, but you can see the construction of it. This is in the days before any integrated circuits were being used in the whole field for satellite tracking. Each one of these little fellows is a little biscuit with transistors, and they had probably 3, maybe 4 logic gates built onto those little boards and plugged into, and you can see there's a row upon row upon row of them, and stacked upon stacked upon stacked there, and they were forced back into the back of that big unit. A particular one I worked on had a massive flashing light display up there, and there was a young Irish girl who was actually a computer operator who actually looked after these computers, and she could virtually listen to watch the lights and listen to the little speaker that was there and say, the computer's not right, it'll have to be rebooted, and you could guarantee she was right. Banks of receivers. Now, most of these receivers at Auroral were in the VHF range, about 120 megabyte to 150 meg was an assigned band for them. That's them down there with oscillographs built on the top there, tuning knobs all over, and the data, of course, having been received as an RF signal, just as the carrier has got the data modulated onto it. So in between was a raft of demodulators. Now, another thing that's significant in here is a patch panel. There's patch panels everywhere in Auroral, and because we had so many resources and we supported so many different types of signals, both radio frequency and data rate signals, we had to be able to change quickly, not only change between scheduled passes, but if anything went wrong, we had to be able to quickly pick up an alternate facility that was somewhere else, and so you could quickly patch across. So these patch panels were set up for their normal configuration. A later variation was that there was a pre-made patch board where for different setups for different satellites, and they could be literally dropped into a frame. They were preset to send the receive signals, the activation signals, the tracks on the recorder were assigned through these patch boards. They could literally be dropped into a frame and switched into operation. Here. The location. So there's the Canberra City up there on the north side of the lake. I lived here in this new curtain area. Who's familiar with Canberra? No. Anyway, that seems vaguely familiar to me. Parliament House is roughly here. Government House is over here on the lakeside of Cotter Road. Yeah. So all around this, usually the lower suburbs here, the southern suburbs of Canberra, was where we were provided with, not provided with, but where our staff were usually congregated, as well as other people over the border here in Queanbeyan. There, and there was a great cycle of cars, company cars, that took us down the back roads. This was all unmade road until you actually got and made a connection with the Monaro highways, yeah, as it was there. So because we worked around the clock, right through the night, we'd be ferried out, or actually drove ourselves out. There was an assigned driver. We'd drive all the way out here, across a very narrow rickety bridge here, through the little village of Tawa, down the road. There wasn't I think there was a dirt track there to start with. And of course, this is down through those hills that you've seen in that aerial view of an actual picture of the, I think, that was about 45 k's out there. I remember a time when I heard the changeover shift that I went to meet said, "Oh, we've had a bit of strife here that one of the powerhouse technicians, because we're out here, there was a complete power station here in triplicate. It might have been 3 separate generators. So there was a power feed, a mains feed out to here, but it was lightweight, and it was essentially a backup, because on the station was a very big self-contained continuous power generating site. So what happened was that this powerhouse mechanic, just an electrician, was recruited from Queensland. Never been outside Queensland, and he was going to work in the night time of winter, and they came up over one of the hilltops and found themselves in a snowbind, and he was petrified because he'd never actually seen snow or never come near it at all. See that diagram is actually showing a link across the hilltop. So there's the hill that we were talking about earlier, and then in later stages when Honeysuckle Creek was built up, and it. So I could say, well, this map's up here is this is the indication of the three branches of NASA's network. Auroral was the site that supported the scientific unmanned satellites, and they were established in the earliest years of the space program to do evaluation of the Earth's atmosphere that the manned flights would eventually have to cover. Honeysuckle Creek was the support station for the manned flight network itself, and came a little later, had somewhat different operation requirements. For a long time they would only work day shifts and do installation, and they were regularly off to the US for training courses and other jollies over there, and had a relatively easy sight of it. Over at Tidbinbilla was sitting up on the top of the hill, and had been established some little time before. Was essentially initially a radio telescope. How do you describe it? Astrophysics, radio telescope facilities. So they decided that they would locate and expand the facilities at Tidbinbilla, and that became, because they were working essentially on long distance first of all for optical tracking, and then with the explorers, the surveyors, and that were operating at long distance. So they were fitted out with the larger antennas that I won't talk much about because I don't have any great experience of them, but they were larger dishes to the extent of 64 metres, 210 feet. Yeah, big fellas, and much more sensitive, and they worked at lower data rates, of course, at those long distances, very low signal levels, but did it very competently, and has always had very good reports of the operation, as all the Australian stations have been. No, at Auroral I was working for EMI. Yeah, NASA provided all the funding, but they had to channel it into intergovernmental through Department of Supply, as it was known then. And Supply nominally provided a station director, it was called, who was virtually responsible for administration, direction of each of the stations. There was a station director at each of these stations. When I went there, fortunately, I was under the direction of Tom Reed. You'll have heard of him, a wonderful Scotsman who was a wonderful organiser and manager of people. He eventually moved to Honeysuckle Creek and straightened them out from all the slackness that they'd started with.
Over the years, I've asked isolated. no one's ever been able to give me, apart from the stations, could be. No one's actually, doesn't make
No, it didn't, and that's so. And I think there's a good bit of politics goes into it, both within the NASA networks. There at back in the States, even, and how because there was a kind of director, assistant directors of each of those networks that were looking after their own management. Initially, I think it was valid to have the these two especially, because they were new stations and they wanted them to be considered as separate operational facilities. But as has happened now, Orall Valley only lasted for about 12 years. And in the usual kind of American project management for any kind of a big project, they decide that they want to do a project. In this case, it was prepare for manned flight, and so they provided the funds. They said, we want to do this and this and this, and our team of surveyors and assessors has indicated that this is a very good place to put it. We've looked around Australia. They started off actually, the very first tracking station, I think, in Australia was actually a mobile station out of two vans up in the mountains outside Toowoomba at Kubi Creek. And they operated and kind of proved the facilities that could be provided for the station. More to come of that as we get to Carnarvon, which is essentially there's Australian politics involved here, of course, in that this is a federal territory. So the government and the Department of Supply could say, well, we want it here. We don't want it over here in New South Wales, and we don't want it in the back of Burke, which of course would be a very nice, quiet place to put, because that is actually one of the real criteria of a tracking station. It has to have absolute absence of minimalisation of electrical interference, especially, and even optical interference too, because some of the work is optical. Right, moving on. That lovely big antenna there is the original installation of the Aurorals in 1964, I suppose that was actually installed, built by Collins Radio. A magnificent piece of work, and as you can see, it's now sitting over at Mount Pleasant in Tasmania. When Orall Valley closed down in 1975, after 11 or 12 years of operation there in the federal territory, NASA said, well, we've finished with that. We don't want to use it anymore. We'll take some of the equipment, or we'll take a lot of the equipment out there and consolidate some of it to, first of all, I think some of it went to Honeysuckle Creek, and in later years the equipment has gone back into Tidbinbilla as part of the massive facilities that are there. And they said, well, there's that antenna there, we don't want it. Can you make some use of it? And nobody said anything. There was a big sound of silence until the University of Tasmania said, we could probably use it with a bit of modification for our radio astronomy. And they said, righto, put your dollar down and we'll dismantle it, ship it over Tasmania and reinstall it and have it checked out and it's yours. And that is still there to this day, doing radio astronomy work 54 years later. And it's still as good as ever, they tell me. There's the Tamar River there. They were pretty reliable because they were built to very tight specifications, considerable specifications. What happened was that they were gradually superseded by better equipment. And in the dish itself, they'd refurbish them. They were very well maintained. There's a huge not yet. Whoop, okay. Huge gear. I think the figure was that there was about 100 tons of steel movable above the base. Okay, move on. I spent 2.5 years at Auroral, and I'd always kept an eye on what was happening at Honeysuckle Creek, and saw that the good life that they were living there, and the fact that they were getting very good training resources, whereas we were working hard around the clock, and to put it mildly, I was envious of the situation. So I'd made approaches to Honeysuckle Creek for a transfer, but it turned out I got the final word that under the contractors' arrangements, contracts with Department of Supply, they weren't allowed to take staff from the local station, so that was stymied. But then I heard that over at this new station at Carnarvon, which had been established about the same time as Auroral back in 63, 64, they had what was called a mini track system. Was their first facility. Was essentially a flat array of an antenna, and it was precisely located where they knew where the geographic location of the antenna is. You can't actually see any of it here. In fact, I don't think, no, it wouldn't have even been disinstalled because it had been superseded by the other tracking systems. But it essentially was a flatbed of antennas that literally pointed straight up in the air, and it remained fixed. As satellites went over with their beacon, the mini-track system would pick out the phase difference between the signals as it went over, and they would precisely be able to time where essentially where the longitudinal crossing of the meridian occurred, and from that they would be able to derive orbital details so they could keep track of where it was and where it would be visible at a next station. A whole lot of orbital computation was done back in the States from the tracking data that was provided here. It was all of that was later incorporated in the tracking data that came from the antenna itself. There over here was another form of tracking systems, and here you see another variation of this was I think an acquisition aid, a broadband lower sensitivity receiver that was part of the original installation. And while we're here, measurement, timing, geographical location of the station itself, right down to the very midpoint of the axis of that antenna, and that antenna and those antennas there were all calculated first of all, measured by ground surveyors, and as time went on, and the cross correlation of the tracking of satellites and was fed back into what was actually occurred by relation to the predictions, the orbital predictions that the network had provided, just ultimately refined those places down to within metres of their location, and this is way back before GPS or any synchronous satellites were in the air at all, and of course inside together with that was very accurate clock timing. So in both Auroral and Carnarvon, they had I think both stations had a triple redundancy atomic clocks. They had started off with atomic clocks, then they moved to a cesium clock, and they were accurate to some phenomenal thing, something like 50 microseconds of absolute standard UT, universal time measurements. We picked up WWV signals, and together with the corrections for distance, path length and even from the relevant to the reflections in the ionosphere as well was taken into account. So very precise time measurements and geographical locations. The two had to go together to relate to satellite orbits. Another part of the measurement was over here. This is a collimation tower, and on top of it is a little get up. Where are we? Back to there. Right, over here. Collimation tower. So it had a mini transmitter of the same signal as the satellites. No data or anything. And I think there was also a reflector dish on there. So mainly it was here for the new installation of this 9-metre dish here, and before each pass, well, not necessarily each pass, but regularly, at least every day, would be the antenna would be pointed over to there and double check that it was it was measuring the same here as it did yesterday and all last week and all last year as well. So another one of that. That's the power station for Carnarvon. And what we've got there. So this was the original installation there, heavy air conditioning facilities there. And that was to service the original mini tracking system. As we got into the Apollo series of launches and this 9-metre dish, again, it's an ASL, a bigger pardon, it's an XY mount. There's the gear wheel of the north-south. That's the north-south axis. That was installed, as was this new building, the TNC building, Telemetry and Command facility. I think these were the WWV timing standard receiving antennas. Over here, was a solar SPAN, solar particle alert network. So again, some of the lower level of experiments and coverage that was performed here was a constant monitoring just through an optical telescope, small bore telescope with some kind of detector on there, and I think a chart recorder, slow speed chart recorder, to monitor the occurrence of any particle bursts, solar particle bursts, because that was essential for the to know about what was likely to happen as the Apollo astronauts would be venturing out of the Earth's atmosphere, and the protection that prevented. There's virtually no protection from anything once you get 250 k's up above the Earth, and the atmosphere peters out, and you're in a vacuum of space, and everything gets hit. That's the layout of the Carnarvon site. This is the northwest coastal highway. Now, Carnarvon, going back to the location of sites, there was Stadan sites supporting the scientific satellites scattered all around the world, and I've got a map here that it's available to have a look at it. There was sites right at Cape Canaveral. There was a small place called Myla Island, which was just immediately adjacent to Cape Canaveral, where the space craft were launched from, scattered along the sites, various sites of Cape Canaveral. But they were too close to actually. They just monitored the immediate liftoff. One of the important stages of launch is to ascertain that that the spacecraft has actually established an orbital speed and an orbital height to do that. Now, I can probably yeah. Now there's this one. Peter could hold it up for you, and because I haven't got a slide of it, but there's so here's Cape Canaveral in Florida. The majority of satellites were launched at a southeast trajectory. It varied according to where they actually wanted to place the satellites originally, but predominantly they were launched in a rather narrow channel down there. But unfortunately, that disappears right across the Atlantic and down the gap here. They usually come down to about a 35-degree latitude, almost miss South Africa, and then start to return up here. And lo and behold, they cross Western Australia coast. The only stations that NASA had were on that's Ascension Island there, and Johannesburg there, but that was too far away for an actual launch trajectory to pick up the signal as early as possible and ascertain that the bloody spacecraft was actually going to go into orbit and whether it needed any corrections. And so just literally by orbital calculation, it was shown that it was necessary to have a tracking station somewhere on the west coast of Australia. Coober Pedy was sitting up here in central Queensland, but that wasn't a permanent station, and the stations at Aurora and Honeysuckle down in Canberra district weren't in any position, because most of the craft would be passing too far away from there. There's tracking stations all over the world. At Madrid, there's a big deep space dish at Madrid. They're over there in the Mojave Desert, out here in Hawaii, of course, in the Central Pacific. Over here, there was about 13 of those stations. Thanks, Pete. Scattered around there, but Carnarvon was a critical location. Had the benefit of being isolated, away from noise. It was only 10 kilometres out of Carnarvon, but Carnarvon didn't make too much noise. So at Carnarvon there was the 9 metre dish, relatively small as things go, but it was a very functional unit, and back there, and did an enormous amount of work through virtually everything that was launched from Canaveral was picked up on its first launch pass through Carnarvon. While we're there, this is just something that was constructed by my senior engineer, a wonderful Italian guy named Monte Sala. He just decided after a few years that he'd do something for the station, and just designed this little plaque here, lovely little fountain. There was an operating fountain there. You can see there's a Gemini spacecraft here, an orbital ring, and that stood in that location for 30 odd years, and unfortunately started to deteriorate after 30 odd years, and his family have recreated it, and it's now a replica of that is now in place at the Carnarvon Space Museum, just outside Carnarvon Township, again at the Overseas Telemetry O2C location, which actually just handles commercial communications. There. Another major function at Carnarvon was the Q6, the FP Q6 tracking radar, purely for tracking. The only signals it would receive would be a transponder signal, and was used again for precise tracking. Was probably more precise than the data that came from the signals and data, the telemetry antenna, what was called the USB antenna, the 9 metre antenna. I think this was only 6 metres, 6 metre dish. Yeah. Well, it would pulse a coded signal from here itself. There was a bimodal transmit and receive to the satellite, which would translate it back. Now that came to be okay for low Earth orbit satellites, and but then of course it was realised that the transit time, even the transit time of signals from the Earth to a long distance kind of what do they call it, cislunar, in the path between Earth and the Moon, was going to be a significant variation to give a precise signal here. So one of the things, we'll get to that. I might even go back to this antenna was a wonderful composite design, in that it wasn't just a simple receiver of signals. It was known as a USB. Nothing to do with what the USB is these days. It's a unified S-band multi-mode receiving and transmitting signal. The earlier spacecraft, the Gemini, had the Gemini signal had used about 5 different methods of transmitting data and receiving data. They'd used VHF here and UHF somewhere else. They even used some HF, I think, for very low resolution, just to pick up the position of the satellite or the capsule, whatever it might be. But it was realised pretty quickly on in the development of the lunar missions that they would need a much more precise system of ranging, first of all, and they had got another early system that was called range and range rate, which sent a coded signal, which is again a bit like the modern day GPS signal, that the satellites transmit a random code, but it is defined, and your local GPS, whatever it is, whether it's a separate unit or even your phone, deciphers precisely when that was transmitted and synchronises on it, and by receiving several different signals these days from different satellites, it can do very elaborate trig computations and figure out where you are, because it knows where it is precisely much better than you do. But this system was built into the radio systems that were supplied with this antenna, and known as the unified S-band. S-band is a band of available frequencies in the 2.2 gigahertz data, and on the S-band signal, they managed to multiplex not only the telemetry data from that was being sent from the capsules, from the astronauts' capsules of the various types, but the biomed data, just analog data, voice signals, the ranging signals, and in this time, because it was all integrated within the one radio stream, it became a much more accurate tracking device. There. Yeah, that's the radar. There's something that we saw occasionally, a great big constellation antenna, aircraft packed with radar. And again, this was, it had 2 main purposes. It provided us with simulation and exercises, which were a constant demand on the stations. That there was procedures that were laid out in massive volumes of documents for every satellite in the say back in the Stay-Dan facilities at Aurora, but more so in the Apollo systems that followed. NASA, of course, had come out of somewhat military organisation procedures. So there was plenty of design work went into what was required, what was the objective, what's the ways of doing it, now what's the best way of doing it, and how will that be achieved. We have to start here and proceed through here, through here, through here. That's why there was the State and network that did the basic scientific research into the atmospheres that and environments that the astronauts would ultimately go into. Then there was the other sideline of how do we keep track of the stations? How do we communicate with the satellites and the astronauts? And what's the procedure? We expected to do this, and we will then follow with doing that, and we'll get to the end. If it doesn't do this in the first stage, what are we going to do about it? So there was always a contingency plan available. And if that contingency plan can be repaired quickly, then we can get back on track. Otherwise, we have to either stop or we have to take another emergency contingency aspect. So we did numerous simulations. This was another variation of a flying astronaut capsule. It had all the similar equipment that would be on an Apollo command and service module, CSM, and even the lunar modules and that. And so this craft would fly over the station, fly around it in circles. The antenna would have to be able to pick it up because actually this used to fly out of Perth virtually every day. There was only a dirt strip at Carnarvon, so this would fly up in the morning of simulations, and these would go on non-stop for about a week. We'd work every daylight night, and then they would actually sometimes come back at night for another purpose that I'll tell you. So these there would be a very experienced capsule controller on board, and there would be another team at the station that had come out specially, and they would supervise and monitor how the local station crew could handle the basic routines that were required to communicate with to send the signals at the right time, to receive them, to set up the equipment the right time, even to the extent of the recorded data that they provided, and that they could then assess what needed to be done. And they used to provide very comprehensive and very substantial and hard-hitting reports sometimes. In the early days, they would just pick holes in what was happening at the station, and it'd be taken into account. Yeah, sure. And the second purpose of this station of the aircraft was again for geodetic location. It had a laser reflector and a laser lamp, and so it had come out at night, pick its nice cloud-free nights, and the people, the other staff on the ground would take high-resolution images of that craft, and essentially they were only interested in the laser pinpoint light against a star background. So everybody knew where the stars were, and they would then analyse the photographs that they took, and again refine the geodetic position of the station. So that was that. Now, that looks like a tracking station, but it's not. It's actually this is up the road at what is now the Carnarvon Space Museum, and this is on the site of the OTC communications tracking station. It's only about 3 or 4 kilometres from the tracking station, but there's not visible here. There's not another slide of this. Okay, over here is just out of sight. Here is one of those shoehorn dishes, which you may have seen probably from the UK, from the Jodrell Bank facilities in the UK. A complicated thing, but essentially it's just another form of a reflector with a very sensitive receiver built into it. And this is a newer version, which is just a basic reflector dish with its Cassegrain. Could be a Cassegrain reflector disc there. All very, very accurately aligned. The whole surface of that dish, whole 200. No, that's a 30 metre dish. But the whole acreage of that dish, all the panels, are probably within about 1 or 2 millimetres of a absolute spherical section. The end. There we go. That for the slides. I was going to talk about the townships and how they vary, but that's probably something even from another time. Would do. If anyone who would have any questions, as you like.
Mentioned
Mm-hmm.
Obviously you needed to see the
Yeah.
Globally
Yeah.
back in Vitalics or something?
Yes, by telex. Yeah. It, well, one of the miracles I thought of all the things that happened in the network was the computation of orbits for every one of these different stations. I'm just looking for an old telex message on a favourite piece of paper. Yeah. So an old-fashioned. Is there anybody remember a teletype message that comes out of things? Usually clickety-clack. This is a modern version. It's on thermal paper. It was actually printed on thermal paper. But the network controllers, who had all the information of what they were trying to manage, would schedule which station would be scheduled to support a particular satellite, and they would have a calculation ready of when it was going to appear on the horizon. The before each of the scheduled passes now at Auroral, I first encountered my first computer back in 1965, and it was a PDP-8i. It was about this big, and I think it probably could be contained in your fingernail these days. And before each of the passes, we would get the specifications for a satellite, and it'd be coded. It'd probably only be half a dozen lines. It'd just say, addressed to Auroral, a satellite pass beginning at a specific Greenwich time. Everything happened in Greenwich time zone Z, for universal time, and it was followed by, I think, 5 or 6 groups of figures, which were the orbital parameters, the epoch ephemeris. Ephemeris is a word that I came to. And these 5 characters, with the teletype message, came the punch tape, and we had to feed the punch tape into this little the reader of the PDP-8, and it would go into its own little calculations and predict the horizon computation for the upcoming pass, and it would actually just spew out a printed copy of every 10 seconds the parameters for. Yes, with valves. It was a valve servo driven. So you had these a small rack of valve driven servo things, because the antenna would had a quadrature phase receiver actually, and so the slightly different phase signals that were received at the centre of the antenna would be fed down to detectors, and the offset between one phase and another would indicate how far the satellite was off from the alignment of the antenna, and those signals, minute little signals, would be amplified in this servo amplifier. They were the most unreliable thing I've ever seen in my life. You could send that whole 100 tons of antenna, movable antenna, into an absolute quiver just by flicking the tube. It was horrifying. And if you did it too hard, it'd get out of track and it'd just go nyom, and slam itself down onto the virtually onto the apron. Any more devastating questions? Go. Those kind of things, yeah. No, I don't think I ever actually met an astronaut while I was there. Yeah. See, we again, for a lot of the time we were working around the clock too, especially in the lead up in those last 2 years, 68 and 69, were really hectic, and we would be doing simulations, and another terrible term that was used was CADFIS. Command and Data Flow Integration System Simulation system, and that essentially was a on the ground. It would vary in extent, but there was simulation of the signals that could be received, and it was assessed how we processed it right through from a simulated radio frequency fed into the antenna, how the receivers were coping with it, how the demodulators were coping with it, and how the computers were processing it, how the purpose of the computers were to essentially of those duplicate computers that I showed you earlier with the big trays, essentially were to strip out the mass from the mass of data downlink to stream out essential information and feed it down over our super fast landlines, which could cope with about 8 kilobits a second in the main. And it wasn't actually until we got our own satellite links directly, because most of the transmission out of Carnarvon was by landline with the usual limitations. There you go.
Well, thank you, John. John's going to be around for a little while longer. We can jump up and have a chat to you in our break. But thank you very much. It was a great. Just have to keep moving tonight because we've got a bit on the cards and we want to have a little bit of break. Thank you so much. It was really fascinating. Just got a quick segment we're going to do on a monthly basis. We're calling it Australian Space Agency Watch. As you probably aware, we do have a space agency now. It's over 12 months, and we thought we'd do a monthly recap of what's been going on with the agency in the last month. So, of course, this month, what I've done is I've put in the various press releases from the agency. I'm not going to read every line, but basically they're talking about establishing this Space Infrastructure Fund and International Space Investment Initiative, which are two programs designed to spur Australian space activities. Projects under the SIF include the mission control in South Australia to support businesses and researchers controlling their satellites, Robotics Command and Control Centre in WA to support robotics and automation, and they're calling it the Sydney Aerotropolis, which I think is a great name, and also supporting facilities in Tasmania to track space objects. So a little bit more news on this front in a couple of slides, but this is part of the initiative of how the agency is sponsoring or performing encouragement in the Australian domestic market to try and get things moved along. So they ran in June, July consultations for the design of the International Space Investment Initiative. September the 5th, Space Infrastructure Projects, they've opened up consultations from the general public and I guess from industry, and that's open until 24. So only a couple. Well, is it tomorrow? Yeah, tomorrow. So jump in. Once again, it's all about the 7 targets for common user platforms, and once again, they're running consultations on how to inform the program design of the 2 projects: the Mission Control Centre in South Australia and the other centre over in WA. So jump on the website, follow the links there. There's also face-to-face consultations, information session in Perth, actually today. So I guess if you're watching this, you might have already been to it, hopefully. Maybe someone will tell us what happened. The Space Agency inaugural advisory group had a meeting on the 5th of September. And basically they're there to set the strategic direction of the agency, the overview of the Australian space civil strategy, priority areas, agency programs, and of course the Space Infrastructure Fund, how that's going to be run and distributed, and the International Space Investment Initiative, business development, etc., etc. I thought I'd just quickly give you an idea of who is in this. This is Professor Freeland. This is the advisory committee. He's a Dean and Professor of International Law at Western Sydney University. Lisa Harvey-Smith, a well-known media person and all over the place as far as what she's doing in the field. She's part of CSIRO's Australian National Telescope Facilities. Professor Peter Kinken, AC, Chief Scientist. Lincoln. It's a bit hard to see with my old eyes. Lincoln, kind of thing. So, Chief Scientist of Western Australia. Pamela Melroy, she did something with NASA, I can't remember. She flew a space shuttle or something. She's heavily involved here in South Australia, especially with what they're doing. Involved with Nova Systems. Dr. Chris Pigram, he's a member of the CSIRO Deep Earth Imaging Advisory Panel, etc., etc. Mr. Frank Robert, Associate Vice President at AT Kearney. I don't know a whole lot about him. I could have researched it, but didn't have time. Professor Margaret Shield, AO, Vice Chancellor and President of the Queensland University of Technology, member of the CSIRO Science Industry Endowment Fund, and some bloke named Andrew Thomas. I don't know what the hell his claim to fame is. But it's nice to see him being quite vocal and active in the Australian... Yes, well, this slide is a slide I never thought I would put up here at a meeting, but there it is. So, this is real.
Today it gives me great pleasure to announce that Australia is once again supporting the United States in another historic endeavour. We are joining NASA's campaign, Artemis campaign, to return to the moon and to go to Mars. The Australian government will commit $150 million over 5 years to support the mission and related activities, and I expect that's just where we're going to begin. This investment through the Australian Space Agency will give Australian businesses and researchers the opportunity to bring our capabilities to NASA's Moon to Mars mission, and it will give Australian businesses the chance to compete for a place in growing international space supply chains. The Australian Space Agency will work with NASA to identify how it can support a significant part of its mission. This can be developing automation systems that could support exploration of the moon, or be used in the Gateway, that's the spacecraft that will orbit the moon as a home base for astronauts, creating Australian components on space and lunar vehicles, or using Australia's experience in mineral exploration on Earth to support scientific investigations on the moon and Mars. We're pretty good at mining in Australia. Our space agency will also support Australian companies and research organisations to do work that can support the US mission. And these activities will help us reach our goal of creating 20,000 additional jobs in the Australian space industry by 2030 and tripling the size of the Australian space sector from $3.9 billion to $12 billion. As I said with the President yesterday, we're about jobs, and space is about jobs as much as anything else. And the benefit will flow onto other areas of the economy by applying space technologies in agriculture, emergency management, and our mineral sector, just to name a few. So yet again, Australia standing together, looking up into the sky together with the US. We've partnered on space exploration for more than 60 years, and with today's announcement, our space cooperation is set to continue into the future. With the Moon to Mars mission, the United States is again leading the way, lifting our sights, exploring the frontiers of the skies, and expanding humans' presence deeper into the solar system. But most of all, I think, capturing our human imagination. The daring and brilliance is a great inspiration to all of us. I commend President Trump on his leadership in this respect. This daring and brilliance is something we can aspire with him to. And we can't wait to be part of the next stellar chapter. So beam us up.
Okay, beams up. All right, so then they followed on, they signed an MOA with NASA. So it's nice to see the leader of the country talking space, at least. So I thought I'd run that whole segment there. We'll see what comes out of it. I already heard that Barnaby Joyce said something today about, why are we spending money going to Mars when there's a drought on? So, yeah. So this is the nuts and bolts. He's laid it out, basically $150 million over 5 years. I won't read all of these segments here. And Megan Clark, the investment will allow our businesses and researchers to contribute Australia's best ideas and technology to support NASA's plan to return to the moon and onto Mars. So who knows where this might go, or whether it will go anywhere. So it'll commence in 2020 to 2021 with the next step involving Australian Space Agency working with NASA to confirm areas of interest as well as implementation arrangements. Areas of investment will align with the Australian Civil Space Agency 2019-2028, I should say, and identified civil space priority areas. So watch your space. Pardon the pun. All right, well, with that, we might take a break and we'll come back with global space news and planetary news. And stand up, say hello, ask John some more questions, and we'll see you back here at 9 o'clock, which is 15 minutes now. Thanks. Okay, ladies and gentlemen, we're going to pick up with the program, just so we can get out of here at a reasonable time tonight. Thank you for that. So we're just going to pick up a bit of Australian space news, just a bit of a follow-on to what was been happening earlier. So the South Australian Government supports local launch site with a development announcement. So the South Australian Government has proposed the Southern Launch Space Launch Facility as a major, designated as a major development, opening the way for development of the site at the bottom of the Eyre Peninsula. Although well south of the most efficient equatorial launch locations, it's well suited for polar and polar-like orbits. So there's two other launch sites that are in the works as well, the equatorial launch up in Northern Territory and another one in Queensland, but it's a bit fuzzy about where that might end up being. So the proposed launch facility has been designed to compete globally on rocket launch schedule availability, launch window flexibility, and launch site accessibility. So this is where it is if you want to take a look. That's where the Whalers Way Orbital Launch Complex is proposed to be built. So Whalers Way, here we come. Yeah, that's right. I've just read that. Some other Australian news, space news. Adam Gilmore, the chief executive and founder of space company Gilmore Space Technology, has been awarded this year's Advance Award for Advanced Manufacturing. His low-cost hybrid rocket support in the Australian space industry, etc., the technical developments that he's been involved with. Gilmore has developed hybrid rocket with 3D printed fuel, the aim of developing a lower cost launch capability. So they've had an interesting history, and they were supposed to have a launch earlier a couple of months ago, but they had some technical issues, so they're trying to recycle themselves back up to get that happening. More news to come on that, I suspect. The video of... No. Interesting. Okay. So there's a video of the launch attempt. So was it a problem with the rocket or a problem with the ground facility? Oh, okay. Right. Okay. Oh, wow. Oh, we'll see, we'll talk about that and have a look at that next month. So there's no ignition of the engine itself, it was purely a gas pressure.
I think you got to 17 again.
Right, okay. Okay. Black Sky Aerospace, rockets towards manufacturing solid rocket boosters. I'm not going to, this is the press release, which actually I believe came out today. So they've been given the green light by regulators to begin process towards manufacture of solid rocket motors. So it's a Southeast Queensland company, and there's some other local involvement here as well. I won't pretend to give you the whole rundown, but it's exciting information. Director of Black Sky, Blake Nikolic, our propulsion arm is integral to the bigger picture for us. Without fuel, the industry stalls. Our solid rocket manufacturing provides industry with accessible rocket boosters made right here in Queensland. So there we go. I saw something on Facebook tonight, and I don't know if anyone caught it, but apparently there was supposed to be a news report on Channel 7 tonight. Whether that was national or whether it was in Queensland, Channel 7 News, I guess maybe we can jump online and hunt that up. So, anything you want to add? No?
I think the key thing is that the Melbourne State is working towards manufacturing solid rocket motors in Australia. That's quite close, and we expect to have the first test batch of solid rocket motors before Christmas. Not space shuttle booster size motors, we're talking about qualification motors that may be
Okay.
but to prove that the production techniques are stable to allow us to characterise.
So for those who don't know, David Boyd, and he's been involved with Black Spare. Now we're going to have, as we advertised, Troy McCann here tonight. Unfortunately, he had to pull out this morning. He had a family emergency, so he sends his apologies. Okay, so we'll just go to take a little bit of a global look at the space news. Andrew's going to follow up with some planetary news. Just on the commercial crew program, obviously NASA's contracted with Boeing and SpaceX to provide human launch capacity up to the space station. SpaceX are preparing for a launch abort test before the end of the year. And it's another demonstration test that's going to verify the capsule's ability to escape a falling rocket. In-flight abort has been delayed several months due to the explosion that they had on their Crew Dragon back in April. They feel that they've got a good handle on what happened there, but it's obviously pushed everything to the right a little bit as far as their testing program. And in fact, that capsule they're going to use, or that we've got just damaged or destroyed, was actually going to be used for this launch abort. So now they've had to use another one that was in the production line for this launch abort. So they're hoping to be October, November timeframe for that, and hopefully by the end of the year they're hoping for their Demo 2 flight, which will be actually the crewed Dragon flight to the space station, but once again that might push to the right. I basically said all that, I think. Alright, we've done that. Fantastic. Boeing CST 100, the Boeing competitor for the SpaceX Crew Dragon. They've not announced a launch target date for their first space mission. You'll probably recall that SpaceX had their Demonstration 1 unmanned launch of their vehicle to the space station, which is quite successful. Autonomous docking and the whole smash, and landed, and from all reports, or most reports, it seemed to go pretty well. I think there was a couple of issues they had on the parachutes coming down. Not that it was a problem, but it wasn't perfect, so I think they've got a bit more work to do there. As I believe Boeing has got trouble with parachutes. You'd think parachutes, in 2019, you'd think they would work parachutes out, but obviously there's still stuff that we need to learn about parachutes. So what they're doing, Boeing are looking at having an unpiloted piloted test in October, and the pad abort test they will have shortly after that. So SpaceX have already done a pad abort test a couple of years ago. I think they did that. The Boeing spokesman said on Friday, the October time frame remains a target for their orbital flight test. And just a bit more on the Starliner, it's being developed in cooperation, obviously, with the NASA commercial crew program, designed to accommodate 7 passengers, a mix of crew or cargo, low Earth orbit, they carry obviously NASA crew to the NASA to the space station, etc. Starliner is designed for land-based returns rather than water returns, a first for space capture built in the US. The landing system includes parachutes as well as airbags. So I think they've done a few tests on that. Yeah, Takata bit. Yeah, they got a bunch of cheap ones. Don't know where they came from. They're saying the Starliner is reusable for up to 10 times with a 6-month turnaround. So we've heard all about that, haven't we? And also features wireless internet and tablet technology for the crew. So there you go. They'll be able to watch their movies all the way out. Russia says it's going to keep the source of the hole. On the soil is a secret. So apparently the Russians have worked out where the hole came from, but they're not going to tell anyone. Administrator Bridenstine has promised to speak personally with the head of the Russian Space Agency. They've not told me anything, he said, emphasising he wants to keep good relations with the Russians, one of the 2 partners on the orbiting complex, the space station. I don't want to let one of them set the relationship back, but it's clearly not acceptable that there are holes on the International Space Station, referring to the 2mm hole in the Expedition 58 crew found on the Soyuz spacecraft. They end up patching it with epoxy and manage to complete the mission, but not what you want. But interesting to see what comes out there. Hopefully WikiLeaks will find out for us. The SpaceX Starhopper on August 28 had their test flight, which is pretty cool. So this is the Starhopper. Basically it's a test bed. They've got a single engine there, and this is the vehicle after the landing. It's only going to have this one flight. Apparently it's retired after that, and they're going to move on to the main vehicle, which is the Starship, which is under construction in two locations. Actually, they've got one being constructed in Boca Chica in Texas, another one out in Florida. So they released a couple of photos here showing the vehicle, which is called the Starship Mark 1, being assembled. And standing, it's all open air construction, so it's an interesting process they're going through there. They're also building a similar one, Mark 2, at the Florida facilities, which you may or may not have seen pictures of that as well, which apparently, I don't know how they're going to move it out to the launch site, but they've got a process for that. So apparently they're talking about some sort of intra-company competition on who's going to get their vehicle built first. So fascinating. So this is showing some photographs of the construction of this vehicle. I won't really read all of that text for you. Currently envisaged will support 6 Raptor engines, while the Super Heavy will be powered by 35 of those engines. Those numbers could change, however. Musk is scheduled to give a Starship design update on the 28th, so a couple of days from now, so that should be interesting. Didn't the Russians Soviets have a big rocket with a lot of engines on the bottom? That didn't turn out too well, did it? Yeah. So this is, they've put these fins on it now. So interesting. All right. Yeah. So the Orion spacecraft, which is NASA's manned vehicle for deep space, which will fly the Artemis 1 uncrewed lunar mission, which is essentially kind of an Apollo 8 type mission. It's been prepared at the Plumbrook Station in Ohio. And Lockheed Martin's completed functional checkouts of the crew and service module, which the service module is from European Space Agency. And they were put to environmental chamber to do simulated deep space and thermal protection system tests, etc. In the flight configuration. They're projecting to be ready for its airplane ride to Plumbrook in October, early November time frame. The SLS, that big rocket that NASA's been building for the last how many years, they've finally got all the core stages bit together on the 19th of September in the Moonshot facility in New Orleans. 112-foot tall core stage, adding the engine section to the back of it. 5 stages, which comprise the main structural component, have now been joined, and the stage should produce 2 million pounds of thrust, in addition to the 2 solid boosters producing combined 8.8 million pounds of thrust. So that compares with the Falcon Heavy, Falcon 9, which is 5 million pounds of thrust. Seven and a half, that's right. It weighed 6.5 million pounds.
Nearly $3 billion out of budget. And in the last 5 years, they've been rewarded with $400 million in performance bonuses. It goes to show you something about the American procurement process was.
Sounds like the CEO's getting their bonuses when everyone else is getting losing jobs. So the members of the House Committee in the US expressed scepticism about NASA's reliance on the commercial launch vehicles to carry out human lunar landings by 2024. They basically came to the conclusion that doubts that the NASA's current approach and cost and schedule problems like the Space Launch System, Orion, have suffered. It could achieve the goal of returning humans to the moon by 2024, so they're doubting they could make it. Agency witnesses from the hearing, Ken Bauer-Soxy, acting Associate Administrator for Human Exploration and Operations, contributed to that scepticism by being asked, how confident are you that we'll have boots on the moon by 2024? His response, how confident? I wouldn't bet my oldest child's upcoming birthday present or anything like that. Bauer-Soxy responded, but we're working as hard as we can, so there you go. I think I'd like my pilot to be saying, I'm not sure we'll land, but I'm working as hard as I can, you know. Yeah, exactly. Virgin Galactic, the spaceship and the spaceship company have announced new milestones for the assembly primary structures for the second Spaceship 2 in its current fleet. The sister Unity spacecraft, yet unnamed vehicle, is set to launch customers into suborbital space by the 2020s. So they're preparing for their first customer flight. Once again, start date has not been revealed. Japan's Planetary H2 transfer vehicle, 8th journey to the International Space Station, was scrubbed due to a fire on the launch pad. Liftoff from the Takashima Space Center was scheduled for 6:33 Japanese time, due to separate in low Earth orbit a few minutes later. I don't know whether anyone saw the video of that. It looks pretty scary, but it seems like it must have been related to ground equipment and ground. Yeah. It was ready to go. Everyone was holding their eyes. Anyway, it looks like they've solved their problems, and apparently they're going to be got a target liftoff of Wednesday morning at 2 a.m. local time, 2:05 our time, Melbourne time. So if you're getting up in the nightclub or if you want to stay up, well, I might not. You might be able to watch that. The Indian Space Research Organisation, their Chandrayaan-2 lander, Vikram, failed to have a successful landing on the September the 6th. Everything seemed to be going well, but the numbers froze and fell silent on the last phase of descent. So they've had a couple of weeks of silence. They've imaged. They say they've imaged the lander on the moon. They couldn't tell what condition it was in. They were hoping that the Lunar Reconnaissance Orbiter was going to be able to try to spot it. Apparently they failed to spot it, but apparently the actual time it went over was very, very near dusk, so not a very ideal time to be able to view it. So it's probably not unexpected that they didn't see it. So, but obviously they still haven't heard from it. So whether it's in one piece or many, I guess we'll find out soon. Space is harder, right? Yeah. Do that. Lunar Gateway. This is NASA's concept of the Lunar Gateway. That by 2024, they're going to have this Lunar Gateway where they're going to be rendezvousing with it, and then they'll do the landing onto the moon from the gateway. So NASA's ploughing on with the procurement of this system. So they've comprised two modules, the power propulsion element and the habitation logistics outpost. They're going to have a very basic first phase of the gateway. They're going to do it in collaboration with Canada, Japan, Europe and Russia. NASA officials reported good progress in the gateway development at a recent American Astronautical Society Wernher von Braun Memorial Symposium. So they're scheduling the PPE for power propulsion element in 2022, followed by a year-long checkout period. Once in orbit, that will serve as a platform. Then there's HALO. In July, announced the plan to award the sole source contract to Northrop Grumman, as it was the only company able to complete development in time for a human landing. It'll be based on the company's Cygnus spacecraft, scheduled for launch in 2023. Also aboard a commercial rocket. It'll automatically dock with the PPE and it'll have a ton of cargo to support the landing. So there we go, it's all going to work. So this is a concept of how it's kind of going to hang together eventually. We'll see. Space debris. Obviously, space debris is a real challenge and continues to be. Just had a very recent one where the Bigelow Aerospace's Genesis 2 experimental habitation module, which has been up in orbit and now defunct, almost had a collision with the defunct Cosmos 1300 satellite. The warning came a day before via Twitter, who cited analysis by the US Air Force's space tracking. 1 in 20 odds are actually quite high in the satellite world. So anyway, it ended up not happening. So they end up whizzing safely past one another, continuing silently on another circular paths about 320 miles above the Earth. So there we go. Yeah, right.
With some nudging.
Century on the box. How are we doing? Right. I thought I'm going to blatantly.
Can I just say the kitchen goes in 5 minutes?
Okay. This guy Scott Malley, he's really good. He does these fairly regular videos on all things space, different subjects, etc. So I thought you'd like to see this. Well, this is 3 weeks old, so he's got another one in the works. But he covers quite a lot of information, some of which I've already spoken about, but also some other stuff which was coming up when he did the video and is now obviously out of date. But we'll run that.
Hello, it's Scott Manley here with another episode of Deep Space Updates. Actually, haven't done one of these in a couple of weeks because I've been really busy with the new house and building stuff for cats and things like that. But yes, tonight, Monday night, please, if you're interested, you should check out SpaceX's Starship Hopper. The plan is to fly this to 150 meters. That is what the FAA is allowing them. Their test flight requires 150 meter ceiling. They can fly as many flights as they like, up to 25 meters, but 150 they're only allowed one flight with less than 30 metric tons of fuel. And I'm not sure how heavy the Starship Hopper is, but with the specific impulse of the Raptor engines, it's reasonable to assume that they can get between 1 and 2 minutes of flight time out of that amount of propellant. That being said, it's big. 30 tons of propellant is not a joke, and in addition to the road closures, the NOTAMs, there was a flyer went out to residents of the nearby town saying, by the way, if this goes sideways, literally, there might be a significant overpressure event that could shatter windows. Please don't be inside while this is happening. You'll have a 10-minute warning. So, boy, this will be interesting. Now, this could... it sounds like this is going to be the last flight for the Hopper. So they're going to strip it down and start flying the regular Starship prototypes, still from Boca Chica, because they're certainly not going to be able to fly this out of their location in Florida anytime soon, with the FAA being so wary. Although I imagine that once they get more than one engine on it and they can demonstrate engine out capability, they'll be allowed more leeway. Oh, yes, another thing that came out of the FAA permit is the insurance has risen from $3 million to $100 million that they have to have on hand in case, something serious happens. I'm hoping nothing serious happens. Elsewhere over the weekend we had Soyuz MS-14, and this was a fascinating launch for all sorts of reasons. First of all, this is the first Soyuz spacecraft launch on top of the newer generation Soyuz 2.1A. That was the Soyuz that's been upgraded. It has a digital control system. Unlike all the previous Soyuz launchers, it doesn't need to be rotated on a platform to its launch azimuth. It just launches and then rolls and then takes off in the direction. But because this was the first crewed flight, or for the first flight of a Soyuz crew-capable capsule, which has an abort system on it, they want to check it out, make sure it flies, so it doesn't have a crew on it, except that it does. It has a robot called Fedor on board, who is sitting in the center seat. This humanoid robot is going to fly to the ISS and do like a couple of weeks of testing up there. I don't know if they're going to do like remote operations or whatever with it, but it's kind of cool to see this in the pilot seat, or the commander seat, and have it, moving its head, looking around. I thought it was funny as well that they still included the soft toy 0G meter, which is common on these Soyuz. Anyway, it got to the space station and then it couldn't dock. There was a problem with the Coors docking system, so they backed off as they troubleshooted the problem, and they figured out that the docking system on the Soyuz was fine, but there was a problem with one of the antenna on the Ploysk module that they were going to dock to. So instead, what's going to happen is they're going to take they already did this. They took the crew of MS-13, their Soyuz was docked to Zvezda, so they all got in their spacesuits, they got in the Soyuz, they undocked, and they very carefully flew around the station. Now, I know this is a one-person job, but they put everyone in that Soyuz ready for return to Earth, just in case they then have problems docking to the station, so that everyone at least has a lifeboat available at all times. So that docking went and happened. It looks great, and yeah, we're going to see if Fedora actually gets to the space station. Obviously, this is not great from a point of view of human-cyborg relations, because we've just created a Cylon, and he's been flying a spaceship, and he's been stuck in a Soyuz for several days, and that is not something I would wish on many people. Specifically, being stuck in the center seat of a Soyuz for several days. And if you've seen the pictures, you just know how crushed up those pilots are. Elsewhere in the world, Ukraine has demonstrated their RD-461K, I forget the number. Anyway, there's some cool footage of them testing an upper stage engine. This was going to be for their Cyclone 4 launcher, which then got cut down after funding issues to the Cyclone 4M. I think what they're looking for is international partners, so any demonstration of this technology will obviously be some progress in that direction. Europe gets a shout out because Ariane Space has picked up a launch from another provider. The Ovzon 3 satellite from a Swedish company was going to fly originally on the Falcon Heavy, and it was going to use that Falcon Heavy's direct injection capability where they could relight the upper stage after 6 hours to put it directly into geostationary orbit. But somewhere along the line, someone at Arianespace has managed to put together a better deal. It's not going to be an as capable launch, so I'm not sure how this works out, but somebody's clearly done the math and done the dealing, and we're going to see one less Falcon Heavy launch. What we're also going to see less of is Delta IV launches. The very last Delta IV medium launched with the GPS-3 satellite. Now, to be clear, the Delta IV medium is the single stick version. In this case, they had 2 solid rocket motors attached to it. The Delta IV Heavy is this one where you strap 3 Delta IV cores together into a single giant beastie, and it is the heaviest launch vehicle that ULA currently offers. ULA, if you remember, was formed by essentially taking the rocket divisions of the people that ran the Atlas and the Delta and putting them together. And the problem in that situation for Delta was that Delta was way more expensive because it used liquid hydrogen fuel, and because it would then fly less, it then became even more expensive. So there's now only a very small number of launches that need that. So the Delta IV medium is also kind of the last link to the previous generation of Delta rockets, the Delta III, which didn't fly very much, but the fairing and the upper stage on the Delta IV medium are identical to the fairing and upper stage on the Delta III, which, and you know, the Delta III had the tank from the Delta II, etc., etc., etc. But yeah, so it's kind of, Delta IV is becoming even more removed from the Delta heritage. The last Delta II flew last year as well. But what is coming in ULA's future is the Vulcan. And in the last few weeks, we've found out what the payloads in the first couple of missions are going to be. Astrobotic is launching a spacecraft to the moon, and that is going to be a payload on the very first Vulcan launch. It's not clear if this is the only payload, but obviously, this is a new rocket, a lot of risk, but they've got a commercial customer for it. The second launch is going to be the first flight of Dream Chaser, so that is one to look forward to. That's going to be a commercial space plane, as opposed to that super secret X-37B, which we're all interested in, but Air Force won't tell us anything about. And since we're talking about US Air Force contracts, there is of course the process right now to pick the next 2 providers for the US Air Force, and the competitors are SpaceX, ULA, Northrop Grumman with their Omega rocket, and Blue Origin. And Blue Origin, in anticipation of the award not going to them, have already filed a protest saying that the system for choosing potential providers isn't fair, it discourages competition, it produces a duopoly, etc., etc., etc. So I think they're anticipating that they're not getting it, but that's going to be an interesting one to watch whenever it comes out. I think this legal challenge will be heard properly in November, but I'm not sure when the award comes out. Regardless, it's an interesting time. India has made it to the moon with Chandrayaan-2 finally entering orbit and sending back a bunch of photos. So it'll be there for a couple of weeks as it slows down, gets itself into a circular orbit, low orbit, and then it'll land, and we'll be looking forward to that in September, and I hope I'll get to cover it live then. But until then, I'm Scott Manley. Fly safe.
I was going to say that Scott Manley's really good to watch. He has regular videos coming out, so he should have another one coming out very, very soon. You can go to his YouTube page, subscribe to it, get updates from him. He's a really clear, concise, talks about all different aspects and has some really good analysis of different things that happened, like when they had that Soyuz abort last year. He went right into the detail. It was really fascinating. Anyway, that's it from me. I'm going to hand over to Andrew Rennie now, and I'll get rid of my stuff off the desktop here. And 2 minutes. Sorry, it was paused. It did stop, yeah, in the background. But some of the stuff's there, so. Okay, so where are we? Here we go.
Okay. Just while Peter's getting that lined up for me, I'm going to show two short, brief.
Stand here, Ron.
Okay, I'm going to show two brief PowerPoint presentations, one from last month that fell off the list, and then one for this month. And yeah, start that one there. And then we'll chug on through the news. Peter's stolen some of my thunder on some of this already. Now, the first PowerPoint relates to the second touchdown of the of the Hayabusa 2s to collect samples. And yeah, I can't see the presentation here. Oh, okay. All right. Thanks. Otherwise, I'm going to be looking behind me all the time. Now, for those who weren't... all right, give me a minute. Okay. So, in July last month, no, it's August. So last month I was going to report on the landing on July. Anyway, here we go. And these are some of the briefing notes from the, all right, going the wrong way. No, all right. So here we've got a diagram showing the crater that was made by the impactor, and it shows you where they were going to touch down and several options and some of the details about the ejector thing that was made by the impactor. Science results are now being published, and in particular they've measured the size and shape of more than 10,000 boulders. And there's more than 4,400 boulders larger than 5 metres, and they appear to be collision fragments. Some of the other results, the boulder distribution has now been mapped. It confirms it's a rubble pile, as I mentioned last month. And the number and density has been mapped by latitude and longitude, showing where they are. And there's more boulders near the equator that are buried. Now, for the touchdown operation, TM is target marker. You can see there's a number of the target markers. I'll show you a picture of it in a later presentation when they dropped another one a few days ago. But the target marker is a reflective object. It's about this big, I think. And they let it go when the thing's only a few hundred metres above the ground, and it drifts down and touches down. And then they use that later, after going back to 20 kilometres to the home plate position. They then come in and use that to guide themselves in to the actual touchdown point where they're going to collect the samples. We see the target marker in the target area, and there's the target markers up on the left-hand picture there and enlarged on the right-hand side there. And you can compare it, you can see the 1 metre mark, give you a scale. For that second touchdown operation, they came into 30 metres, held there for a while, then drifted into about 8.5 metres, and then made the final descent, touched down, grabbed the sample, and back off to 20 kilometres away. The real-time operation of the photographs coming in show the operation down to about 8 metres, during the back off, they shut that off. So if you're watching it in real time, you don't see them moving away, you just see them coming in. These are some of the LiDAR. That's the light. It's basically a light signal, like a radar ranging and detection, but it's using light. And the laser rangefinder is well shown there. So that shows how they approached in. You have to allow for the fact that the asteroid is rotating, and so they have to match the velocity so they don't get swiped sideways, because it's actually at the equator, it's actually rotating quite fast. Again, some pictures from the touchdown operation. And the accuracy of the touchdown was about 60 centimetres or so. When it touched down, it made quite a lot of fragments came out. If I get time, I'll show the movies. This is how they collect the samples. And they've got the capacity to collect 3 lots of samples. So far, they've collected 2. This is the second touchdown. And they're planning to do a third one. More about that later. They've named the touchdown point. You can read that there. I can't read Japanese, so I'll give you a moment to read that name and what it means. So there are the 2 touchdowns that they've done so far. And he's just been given a name. And touchdown 3 will be in the Northern Hemisphere. Back on Earth, they have a clean room ready to receive the samples, and that's the room, a bit like the Lunar Receiving Laboratory in Houston. Many of you will have been to the Lunar Receiving Laboratory. Hands up those who have. Yep. Okay, well, this is somewhat similar. Okay. Now, escape. And with a bit of luck, I'll be able to launch this one. Now, this is the one I prepared for this meeting. And God, I can't see it again. Anyway, I came across this when I was looking for news from ISRO on Chandrayaan 2. And the Indian scientists, in association with people in Germany, have analysed some of the radioisotopes that are in the samples from a meteorite that fell in Kazakhstan. Okay, thanks. Now, you might say, well, how do they calculate that? Well, here's the evidence coming up now. Okay, go forward. Yep. I'm pressing the forward button, but it ain't working. Okay, well, we'll do it with the scrolling. Now, this meteorite was called the Efremoka meteorite, and it was found in 1962 July on a state farm in Kazakhstan, 21 kilograms, and it's a stony chondrite. And what they've done is they've looked at these isotopes: aluminium, calcium, manganese, iron, palladium, hafnium, iodine, plutonium, and these have quite short half-lives, ranging from 100,000 to about 100 million years. If they're in that meteorite, they were not there when that meteorite was formed, because a meteorite is 5 billion years old. And of course, it formed from a solar nebula, which was the debris from a supernova, who knows how long before that. So these were formed in the meteorite, obviously from radiation from somewhere. And the question is where? All right. Yeah. I'm just using the scroll bar. Oh, it's okay now. Right. So using one example, this is beryllium, isotope number 7, and it decays into lithium-7 with a half-life of only 53 days. So it's not going to be there for billions of years. So it can't have been there in the original nebula. And in the scientific paper, you can see the graphs there, which we were not going to detail into. So the beryllium-7, beryllium-10, and aluminium-26 allow us to make these following inferences. The nascent, that is the early sun, underwent multiple episodes of enhanced magnetic activity and enhanced irradiation, and that caused these isotopes to be formed. Now, in order to do that, that needed a luminosity of about 10 to the power 25 joules. And that's more than 1 million times the solar flare intensity ever observed in today's sun. So the only conclusion you can make is that the early sun was much more active than today's sun. All right, so that's it. Now, with a bit of luck, we'll be able to start. Here comes Ashley again, our saviour. Double click on that, is that right? Good one.
It's going back to extend.
And that's control when I want to zoom.
Yep, I think so.
Okay. I did show this picture last month. Very quickly, we were running out of time. The yellow terms are the features that have been recently named. Now, okay. So starting with Alcyonia lacus. Now this is a possible nitrogen lake on Pluto's surface, and it's named for the bottomless lake in the vicinity of Lerna, which is a region of Greece. It's known for springs and swamps. And the Alcyonian lake was one of the entrances to the underworld in Greek mythology. Wrong way. Oh, we'll get there quickly. I'll only go through a few of these names. Right, next one. Now, I've circled them in pink. Shows pink on there, reddish pink. The Alcanto Montes is a mountain range honouring Juan Sebastian Elcano, who lived from 1476 to 1526. He was a Spanish explorer who in 1522 completed the first circumnavigation of the Earth. That's a voyage started by Magellan in 1519. Of course, Magellan didn't quite make it. He'd previously been to Malaysia and so on, so he died in the Philippines, so he nearly made it around the world, the first guy. Now, going this way, I hope. No, we're going the wrong way. Sorry. There we go. Now, the Hanapu Balas is a system of canyons named for one of the hero twins of Mayan mythology who defeated the lords of the underworld in a ball game. Now, I've got a whole lot of these other things named, but I won't go into them because we need to move on to Right. I showed this picture last time. The current plans for returning samples that are going to be collected, hopefully, by the Mars 2020 mission, which launches next year. Mars 2020 will collect samples and deposit them, and then the idea is that another lander will be sent off and will run around, pick them up, and then put them on a return stage, which will go and meet up something else in orbit, and then blast them back to Earth. Well, I have here, going the wrong way, a few little movies showing from the European Space Agency how their section of the thing will work. So here's the capsule being launched from the surface of Mars, docking with the orbital station. And then the next scene shows how they get out of Martian orbit. No, play. Yes, ion propulsion, hence the huge solar arrays. And then we return to Earth. So here's our return capsule going to be there it is, jettisoned, and it heads back to land on Earth. And guess what? Well, we could land it in Australia, I suppose, but I don't know where they're going to land it. All right, so that's the plan anyway. Yeah. All right, next one. This is not Ryugu. This now is Bennu, asteroid Bennu. And these are the target landing sites that are planned for the OSIRIS-REx mission. So they're getting detailed pictures of them. Never remember, wrong way, towards me, right. And so here are the various sites. This is Kingfisher and Nightingale, Osprey, Sandpiper. So there are the 4 sites that they're now considering. They haven't, as far as I am aware, not yet made a decision on which of those targets they will use. That's where they're distributed across the surface of the asteroid. Now to Venus. This is a little movie from the Japanese probe Akusaki, which is at Venus, orbiting Venus. And they did that in 2018, in November. Very reminiscent of the shapes the chevron shapes that we saw from Mariner 10 and also from Pioneer Venus. So, no, Pioneer Venus didn't do those pictures. So this is the Japanese probe. All right. Now, this is an ultraviolet, and we've got a big gravity wave here. Okay, gravity wave, not gravitational wave. Those are quite different things. Akusaki has instruments measuring from infrared through to ultraviolet. and some more of the pictures that it has taken recently. So you don't hear much about this probe, but it's doing good science, and a lot of scientific publications have been made from it. This was published this year, but the pictures were actually taken in June of 2016. All right. Now there's a gravity wave I spoke about before. We get the same gravity waves like that in our own atmosphere, but I'll spare you the photos of those because you've no doubt seen many of them. All right. And I love that picture there. That's actually incredible. A mix of visible light and infrared light, showing the incredible structures in the atmosphere of Venus. Now, moving back to Earth, here is Aeolus. I spoke about that earlier in the year when it was launched, and this is an example of how you're getting, with altitude, at different latitudes, the wind velocities as measured here. Now, this is the first time we've been able to do this. We've been able to estimate wind velocities at the ground by looking at movement of clouds and also by the waves, the effect on waves on the ocean. But this is the first time we've been able to do it. It does it by a LiDAR bouncing off the small aerosols that are in the atmosphere. Okay. And here's another of the Aeolus European Space Agency satellite data. All right. The European Space Agency has also been able to measure the velocity of ice in the Antarctic, and someone ought to show that to Scott Morrison, but well. Indian satellite called Cartosat-2, photographing an area called Kumbh, I can't pronounce that, sorry, Mila. And that was taken in January this year. And here's on the same date, a wider angle picture of it. So sort of detail that you're now getting from quite, well, Cartosat's not all that small, but they're smallish satellites. Now off to Mars, and this is a sunset picture, but it's an eclipse of the sun, shadow of, I forget which moon it is now, I think it's Phobos, it might be Deimos. And this is taken by the Curiosity spacecraft. All right. Meanwhile, we do have Phobos here going in front of the sun, as seen from Curiosity. And here is Deimos going in front of the sun. So you get eclipses. All right. Now, the heat flow probe. Still got a problem with that. I haven't checked in the last couple of days, but last I heard they're still trying to figure out what the hell to do with it. They've removed the cover off it, and the probe is stuck in it at an angle. I did show a video of that last month, so I won't do that again. Rolling Stone. When InSight landed, its exhaust kicked up a little stone and it rolled. So, guess what? Go this way. And they announced the naming of that stone, the Rolling Stone, at a Rolling Stones concert, which was being held in, I'm not sure whether it's Pasadena or Los Angeles at the time. So there's the Rolling Stones, and they actually announced it there. I'll spare you the video, but you can find it on the NASA YouTube channel, the announcement of that thing. It's about a 5-minute video. Now, the Fermi Gamma Ray Telescope, has been imaging the moon, and they've collected the data over a period of time, and you can see that progressively as time goes on, are getting a better and better resolution of gamma rays coming from the moon. And the gamma rays, of course, are being reflected off the moon's surface from other sources. I've given up trying to keep track of the new moons that are being, planets being discovered, exoplanets around there. Here's 3 of them. Yeah, there's 4,000 or so of them. And the TESS spacecraft is discovering lots more. Meanwhile, Voyager, there were reports that Voyager 2 had entered interstellar space, but that seems to be a little premature. Voyager 1 definitely is out of the heliopause, but Voyager 2 seems to be sort of, the boundary fluctuates a bit depending on the strength of the solar wind, and it's sort of not quite into the interstellar space yet, although there were reports that it had done so. Evidence, that's one of the instruments that's on Voyager, and you can see that the current suddenly dipped down and then reached a steady state, and that was in 2018. Okay, but since then they've gone up again, so we'll see when it definitively has reached interstellar space. Meanwhile, the Europa Clipper is being tested, made. Here's an antenna test inside an anechoic chamber in America, of course. The Arecibo and Greenbank radar have been making images of nearby, passing asteroids. And there's a nice one there. This is data from the Terra satellite, and it's an accumulation over 10 years of measurements made by the Terra spacecraft. Yeah, okay. Now, this is a fireball entering the atmosphere, and it was captured by the Terra satellite, okay, over the Bering Strait, or the Bering Sea. Sprites. Wonderful thing about digital photography is they've been able to capture these things which before were sort of mythical, and now they're definitely there. So I just thought I'd show a few sprites that were taken in August this year. Okay, a thunderstorm. Normally you see the flash goes down, but often there's a discharge up into space. And they were regarded as being mythical. Okay, so there are nice pictures that were taken there by this guy called Roger Spinner. Now, okay, that pretty much is where the end of the talk from last month was. And so for this month's talk, I'll have to invite you to come back. And I was going to show you the movie of the disappointment that the folks had when Vikram crashed. But Peter stole my thunder on that one, so yeah, all right. So I was going to talk about Didymos and the DART mission and some of the European things that are going on there. But we've run out. Let's just see if there's anything I must say before we go. Andrean, Rosetta. Oh, the new results from Rosetta. March 2020. Cassini. Oh, there's new theories on how the lakes on Titan are formed. So we'll talk about that next time, maybe. All right. Okay.
Oh, thank you, Andrew. And that's it for them. Thank you for coming tonight. Thanks for the speaker.